All right, I believe we are on. So good morning, good evening, good afternoon, good night, wherever you are in the world. Once again, welcome back. We have another amazing session of our deep dive. So today, tonight, or whatever, we'll be focusing on block rewards and transaction fees. And once again, we're joined by Dr. Niraj and also, of course, our founder, Kevin. And it's definitely going to be a super in-depth session as well around all of these. You're going to have all the things that everybody could possibly want. The standard classic Kevin Miro board. It's a necessity by this point. I think it's expected. So without too much yabba from me, I'll pass it over and we can kick off and dive straight in.
Yeah, thanks for that. Good morning, good afternoon, good evening, wherever you are. Interesting session today because I'll be speaking less and Neeraj will be presenting more. I hope so. But just before we start, I just want to give a quick update on the Xperk and the Node NFTs. So, as I mentioned in the announcement as well, the developers found the problems and we have already solved them. Less than 24 hours, we have solved them, but we are intensively testing it. So, as I mentioned, maybe today evening or Monday, we will release it. And the only reason we may not release it today versus Monday is because we have an internal team that we have formed that are testing it right now, and whichever users had connected, we are verifying their balances in both the versions so that you go to data sanitization and you may not have that problem again. Yeah, so that's good. That's one part. And yeah, so in this session, probably we'll look at the transaction fees and the block rewards, and again we'll divide it into two different parts. And the second part of this, we will do it with the second part of the VM, right? Which is the fee calculation on various opcode strategies. So that perfectly fits into the fifth section or the sixth one, which we may do, because the next one that I am thinking to do is do like a hands-on comparison with, let's say, maybe Squid router or XLR network and or layer 0 and Xtalk. So we will deploy two contracts on the chain, try to integrate with layer 0 versus we'll deploy two contracts on on the chain again and do it with Xtalk. So we'll see what are the differential things hands-on as well. So I'll probably code in that and deploy as well. So hopefully next week or the week after, depending on how we go. But yeah, in this one, we'll look at the transaction fees, structure, overall structure of the transaction fees. I have covered up certain parts before, but it's always good to go through it. But then Dr. Neeraj will probably jump into the various strategies that we have formulated in terms of how we calculate fees from the tokenomics perspective as well, or how we calculate fees from the block structures as well, right? So maybe I'll just share my screen, look at the Miro board, and we can kick off from there. Yeah. Awesome. Can you see my screen, please?
Yes, sir.
Okay. So before we go in there, right? So from the fee structure, and this is going to be important not only from the tokenomics perspective that the node hosting people are going to get, but also from the developer standpoint, right? Because certain times various blockchains have various fee models. Like EOS had a completely different model they came up with versus Ethereum has different, Solana has different, right? And it was very important for us to create a fee structure where it remains modular, because from the development standpoint, there are two angles to this, right? One is projects completely built on L1X. The other is projects built somewhere and then use Xtalk for interoperability. And both of them are important because you can build somewhere else, but again, it's like Apple with better stickers concept, which is if there is anyone who can tell me even one major difference between why would I build on Polygon versus Binance, 50,000 L1X coins to them right now in the comment section, please. So there is no pure difference between building on these two chains, right? Yeah, they're faster, but I don't think it's going to take you like 10 seconds versus 8 seconds kind of concept. It's all the same. So Xtalk becomes the most important infrastructure to focus upon when you want to go multi-chain, because when you want to go multi-chain, you have so many different options. Like you got bridges, you got layer 0, you got XLR network, but they come with their own limitations as well, right? And we'll see today what their limitations are. So from the Xtalk perspective, we have two different fees. So one is you register for an event source, meaning I want to listen to something, right? So we call that as a trigger. So how often do you want to listen to it? So let's say if a transaction has happened on Ethereum and there is an EVM log versus the price of the coin, right? So how often do you listen to this information? That's the trigger. And then you have something called as action, which is sending the payload. Somebody has transferred 100. Now what do you want to do? That is the action. So the Xtalk infrastructure has two types of fees attached to it, and we'll see how they are charged as well. On the L1X VM and EVM, we have, again, two types of fees. One is when you do contract deployment, and again, when you do state changing calls. So if you want to update the blockchain, right? So you have fees over there as well. Of course, we have event logs and pure read-only calls that do not have the fees necessarily. But of course, event logs are already charged when you go and initialize a state changing call on the blockchain. Now, let's look at the Xtalk fee structure. And what we'll do is we'll also understand the fee structure of other networks over here, right? Like, for example, Chainlink, Layer 0, and Xtalk. What is this differential point? Now, just so that we understand the flow, right? When you want to listen to something, right? And we'll go block by block. So we'll look at how Xtalk does it, how Chainlink does it, and how Layer 0 does it, right? So two angles. When you want to establish a trigger, how do I listen to X, right? With Xtalk, what you do is you take the contract address, which is what is the contract address that you want to listen to on any of the network. So for example, I want to listen to a deposit contract on Ethereum, right? What is the network? So you could say, okay, Ethereum, this contract address is for Ethereum. This contract address is for Binance. This contract address is for Solana, or program ID is for Solana, right? So you can create these objects. Now, it's not necessary that you got to go one by one, right? You can just put all of them together as an object and pass it on. Now, what is the event name you want to listen to? So for example, when you write a specific function on a smart contract, you can create an event saying that, okay, if a user has deposited 100, then the event should be user deposited. And then you send 100 with that event name. So we know, okay, user has deposited 100, right? And then you also have to mention the Xtalk contract address on L1X. Now, this is important here because this is basically the sending part of it from Xtalk infrastructure to the L1X core. So I have listened to it, but where do you want me to send it? Which is the contract address you want me to send it? Now, this specific contract address, you need to own this contract on L1X because you just can't send it to a random contract. So when you are trying to establish this particular object into the Xtalk registry contract, so we have a registry contract that keeps a track on all these states. You can go in and initialize a state changing call saying that I want to add to this Xtalk registry contract. So once you add it, we know that, okay, this is your trigger and this is the action that you want to take on that behalf. What we do is the trigger or the pricing on this is based on how many times you want to listen to it, right? Because you could say I want to listen to it every 1 second versus every 10 seconds versus 30 seconds, 60 seconds, 100 seconds, 1 year, 1 hour, who cares? So based on the this is very important because if you want to listen to the price of the coin, then you have, let's say, every second. If you want to listen to an event, somebody has sent money, you can do it every 5 seconds to the same contract. So in this way, you could modify how you want to listen and what you want to listen in a way that suits you the best. And the nodes can configure themselves to keep listening to this part of information from somewhere else. Now, how does the other guy do it? Chainlink. Let's say you have an Ethereum contract and you want to listen to that, right? On Chainlink, there is something called as Chainlink jobs. So a job is basically a service worker saying that you have to write a piece of code saying that I want to listen from contract A, I want to listen to this, and then you can take that particular job and then you have to set up an Oracle node. Now, there will be ways on how you can take this Oracle or this service worker and give it to some other Oracle node and then depend on their pricing structure, right? But it can become very expensive. So Chainlink is good if you already have information from their Oracle contracts, but if you go and configure a custom contract, it is a very expensive process, right? How does Layer 0 do it? So Layer 0 basically allows you to go and this is the problem. When you are building a Solidity contract, and any developer can, can second to this, you write your function, you write what the function has to do. Your smart contract has to be tailored according to Layer 0 contract, saying that if you want to be compatible with Layer 0, then you have to follow Layer 0 standards, even in your contract. Now, that means every time you have an update to what you want to listen to, you also have to make changes to the contract. So when you say that, okay, now I want to listen to it, let's say users only sending more than 150 rather than 100, right? Go and update Layer 0 contract, go and update your contract over here. That information could be changed directly into your registry over here if you want it. You could get the 100 in and then put a filter and then send that information to the core. So every time you want to update what you want to listen to, you will have to go in and change the contracts on Layer 0, right? So that is the triggering side of things. Now, what will happen is once you update the global registry, the Xtalk registry is on L1X full validator node. That sends an information to the Xtalk node saying that somebody has registered. Please go and save this in your database. So from the full validator node, it goes to the Oracle node. This is very important because in the previous infrastructures, the more powerful nodes should always update the least powerful nodes. In other infrastructures, you're going from least powerful nodes to more powerful nodes, right? So in our case, the full validator node updates the Oracle node so that it is a deterministic way of updating it, because in Chainlink, all you need is, let's say, access to that particular infrastructure service worker, and you can make changes because that is off chain. In our case, it is on chain. Now, once the database is connected, the Xtalk node will start listening to this information. When the information is actually triggered, it comes to the Xtalk node, and you can run various filters over here. So if I could add, you could establish various filters over here. Now, this filter is of course saved in the Xtalk node. So the Xtalk node also has the ability to send this particular information based on a filter, right? Now, you may have a situation where you want to record all the event logs. Maybe you want to access it at some point in time from the Xtalk node, a cross contract call directly to the Xtalk node. But at certain times, you don't want your contract. So for example, if you say that I want to update the minimum to 150, now you can update the filter, but what happens about the previous transactions? They are still there, right? So in this way, the Xtalk node will send the information to the we'll send the information to the Xtalk contract. We have something called a save event data. This information is stored in the contract, and now you can do what you want in them. How does this work with the other guys? I have to register for an upkeep contract. Now, what is an upkeep contract? Put it this way, right? If you have information coming in from a Chainlink node, you need a separate contract to only listen to it. And then that contract goes and sends it to another contract. I don't understand why. Like, if you go to listen to a speech, why will you send someone else when you want to actually understand that speech? It's not like I don't understand what the person is speaking, right? So in they've got a buffer. Now, this upkeep contract listens to the node, and based on the triggers, it sends it to the desired contract. Where do you want to send it? In layer 0, we'll come to the fee model, but in layer 0, the process works like, if you receive information from an Oracle node, it is their executor contract that has to be notified about it. So if somebody has sent $100 on Ethereum, the event is heard by the layer 0 Oracle. It is sent to the Binance contract, layer 0's Binance contract. And then the layer 0's Binance contract sends it to your contract. That is the source here. In our case, the Xtalk node is decentralized, the FVN is decentralized, and this information directly goes to your contract. So if the layer 0 contract send it to you, who owns this executor contract? That's a good question to ask, right? But anyways, coming to the fees over here, the fee, I'll give you a comparison. The fee over here will be same, like 1 cent, less than a cent, to trigger an action from an Oracle node. So you have brought in information from an Ethereum log into the L1X infrastructure for a cent. In the other guys, because they are relying on like these multiple adapter contracts, executor contracts to pick up and send it to certain other places, there are 2 contracts executing back by back, right? And the cost is going to increase. You've got 2, 3, 4 contracts executing one after the other because of the architecture, right? The cost is going to increase. So you got to make sure that you have enough money in the upkeep contract as a form of subscription as well. And in layer 0, there are 4 types of fees. The initial blockchain fee that you pay and the destination is fine. There are 2 things that layer 0 natively charges: a layer 0 configured security stack fee and executor fee. This is the executor fee which I was talking about. You have to pay their contract to send it to you, right? But what is this? This relates back to this over here, which is, if you go to the documentation as well, when you send an information, you want to listen from layer 0 infrastructure, you have to actually tell them how much security you want. Meaning, they have a model where there has to be 2 recommended nodes and 2 optional nodes. So the model has to pass through 2 nodes, DVN, decentralized validator networks, right? And 2 optional ones. Now, that could mean that if a transaction is above 10,000, then do it from 4. If a transaction is in 500, then do it with 2. Now, this is because the security model is confused, right? Is 100,000 transfer more important than 1,000 transfer? But what if I do 1,000 transfer 100 times? You see what I'm saying? Which is more important? And clog the network up. So in these kind of ways, they have created a strategy on how to upcharge, and these fees are pretty high. In our case, if there are 800 Xtalk nodes, every single transfer, you can configure it based on, of course, your Xtalk private node that you want to run, but you need to have a node NFT. Without that, you cannot. But at the same time, you can configure it with the public nodes. But with the public nodes, you don't get a choice. You can't say, I only want to pass it through 2 nodes, don't do it on 4, right? Because if that is the case, then what about the blockchain state updates? If it only has to pass through 2 nodes, does that mean that only these 2 nodes update their states? What about the other ones? So there is this, configuration required on the security stack that's pretty confusing. But anyways, the only reason I'm comparing is because everyone here understands how much work has gone into the future proofing of this product, right? Like, we have not sat here and just said, okay, this sounds good, let's do it. We have analyzed, researched various things out there. Now, how do we charge this fee, right? As I mentioned, the execution fee is in L1X. But again, this fee over here, you have two types of fee. Initial source blockchain fee, which is paid in the native coin. This is paid in layer 0 fees. This one, right? This is again paid in native coins. So in our case, if you build your protocol or infrastructure on the L1X VM or L1X EVM, right, then this whole concept gets thrown out the window, because now you're not bothered. If you're only listening to it and you just want to issue an NFT, right, you can accept deposits on Ethereum. So you don't have to pay for it, right? The user will pay, but then when it comes through in the protocol, you can directly mint the NFT on L1X EVM. So in this case, rather than paying 3 transactions, you pay only 1 L1X fee. So this allows you to probably even maybe run offers, or allows you a form of charging lower fees to the audience that you may have. Now, we have also gone through this, but I'll probably run through this again and hand it over to Neeraj, because I'm sure she has got a lot to say. In our case, it's a fee deduction model. And what we have done is the L1X VM opcode stack versus the L1X EVM opcode table. We calculate the L1X EVM opcode fees and charge it in L1X. We could charge it in Ethers or Ethereum, but we charge it in L1X, right? For the global, our strategy on a global fee model, which L1X is going to be the global fee. This is, a validation over there. So we've got various transaction types: transfer, deploy contract, initialize, create staking pool, and unstake. Create staking pool is going to be initialized by the node guys. So when the full validator nodes or the event listener nodes want to start accepting stake, this is the contract call they will make. That I want to create a staking pool. These are my commissions and these are my configurations. That is classified as a single transaction. We verify signature and transaction. Of course, the verification happens on chain. After that, for a transfer, it's a deterministic fee model. So if you are going to transfer L1X, right, we will have a deterministic fee model. Actually, we are also working on the ability to have a deterministic fee model if you transfer L1X20 version of the tokens and L1X EVM or ERC20 version of the token. So when you create a token somewhere and somebody is trying to send this token to somebody else, they are paying native gas fees like Ethereum or Binance fee. But what we are trying to do is, and that can fluctuate because it's a contract. In our case, we are trying to make that static, meaning the least amount of fee, like how you transfer L1X. So what would happen over there is, if somebody is building a stable coin with us and is transferring, you would have a static fee model on the stable coin. That's very important, because when you do a transaction today on FROS systems and you pay using the Australian dollar, which you classify as a stable, but it's anybody's guess, you have a set transaction fee. Imagine me charging you a different transaction fee every time you tap the machine. 5%, 1%, 3%, 0.2, 0.1, right? So having the ability of deterministic fee on L1X20 and ERC20 based token will really be very helpful in creating business models. So that's what we are working towards as well. Even staking, so the people wanting to stake into the nodes, even that is a deterministic fee, staking and unstaking. So for the node operators, it doesn't come to the fact that the fees are too high, too low. There's always a deterministic way model, so you can build your business structure around that. Now, of course, deploying contract, there is a fee, but initializing and state changing contract, as I mentioned, we have 2 different versions of VM, L1X VM, EVM. You have to calculate the contract execution fee. Now, the cost contract call, let me give you some example here. When you are trying to make a cross contract call, when would you do this? You've got 2 different contracts. One has the list of people that should be rewarded, for example, and other has the reward logic. So I know who has to be rewarded, but how much to be rewarded? It has to make a cross contract call to the reward logic call. In other protocols, this fee is based on the gas or the units consumed. In our case, there is a set amount of units that will be consumed here, and it will be a deterministic fee rule even in cross contract calls. Now, of course, the units may change based on what is your request and what is your response. But when I say deterministic fee on changing units, I mean there will be a maximum over there. In storage resources, so this is basically you're trying to read from the chain, right? You're reading environment related information. So how many have natively staked? What is the nonce value? What is the transaction hash when you're trying to read all this? And of course, the read contract state as well. So when you're trying to read the contract state, now this is a pure read call. There will be no fees attached to this, but there is a loop. There is a maximum how much you can do, because when you're reading from the blockchain, you read it from like an archive node, and there is a rate limiter. So a rate limiter is how many times can you request it, right? So there is a rate limiter here. Storage resources, when you're writing to the contract and emitting the event. So in the storage resources, again, how many units you have consumed. Now, the units you have consumed, and what is the correlation between units consumed and opcodes? So the way it works is, each and every time you are trying to perform an action, the opcode is executed. When the opcode is executed, there are two defining variables to the opcode, a fee and the unit. So when you go and add all the opcodes, add all the units of the opcode, that's your total units. And when you add all the fees for those units, that's your total fee. So there will be a way where developers can fetch this as well. And emitting the events, of course, there is a fee if you log. It's very low, and that's why a lot of Solidity developers will prefer emitting event logs rather than saving it on the chain. You can save a lot of fees that way. Predictable operations, of course, as I mentioned, transfer and unstake and create staking pool. It's a constant fee, right? So it doesn't change. It's a constant fee. Now, there will be huge, system level libraries that will be called like cryptographic hashes as well, that consume a lot of energy. Now, there will be a constant fee for them, but it will be according to instruction groups, meaning there are cryptographic APIs, there are different levels of APIs that consume a lot of different high level operations, that resources. So there will be a constant fee for them by instruction group, so we can increase and decrease it as and when we require. So this all, at the end of the day, if you think about it, our L1X EVM cost is like dramatically low. So I'll just give you a perspective. Yeah. Take this whole infrastructure. What you see on L1X EVM only, that is equal to Avalanche or Arbitrum. There's no difference. If you deploy an Arbitrum, if you deploy an Avalanche, of course, you can run subnets. Over here also, you can host your own node and run those things. But if you're talking from 80% development cycle perspective, L1X EVM can compensate for all these other ones, but at the same time, make it future-proof for you. So saying that, maybe you don't want Xtalk right now, and you're just trying to build. The only difference is this, and I'll tell you what it is. It is harder to get a grant from us than it is from them. I wouldn't say the name, but we are working with a project where there are layer ones that have given the grants to certain projects, and they restrict them in terms of what you can use and where you can build. So you cannot use this interoperability protocol. You cannot use this. You cannot use that. You have to use Ether's library. You have to use MetaMask. You can't use Trust Wallet. You can't use Rabbi Wallet. So there is this group that has been created with these grant programs. That is where we can't beat them. But yes, we have our own grants program as well. and it is harder to get that grants from us. These guys can't go head on. That's why they require to go in this. They have to rely on other people's money to compete. And I am more than open to get on a call with any of them and discuss this, right? But what is more important right now for us is this fee model is directly correlated to onboarding developers who want to build and also have a way to future proof their transactions or their business model. There is another model we are looking at, and that model is if a developer builds a contract and whatever fees that contracts generate, a certain portion of that will go to that developer. So Near protocol has this feature, right? It's a great feature. I think that it's really good. So we may even look at things like that. But just by looking at a single full validator node, you can see L1X EVM is there. I could go and write a contract right now on hard hat, compile it, put an L1X EVM RPC and deploy it and start using it, right? So in the future, if I want to make my contracts faster, there is L1X VM. If I want to go interoperable, there is Xtalk infrastructure. If I want to change my database to make sure that there are new types of information I want to store, we've got different database types of levels over there, right? So there is this future proofing that even fee is a very big part of. Yeah. So I think that, that gives us a good understanding or perspective on the fee structure that we have thought of, right? But what Neeraj will do is she'll take you through the intricacies of it. Right? I try to keep myself away as much as I can from there because I would get too jargon friendly. But she'll take you through the intricacies of what is a block, how many epochs, the transaction types and their fee models, and all those sorts of things.
Yeah, thanks, Kevin. Hello everybody. Nice to meet you all again. It is every time nice to interact with the community. So let us today start with how we are going to have blocks, transactions, and fees related to it. So I'll just share my screen. Just give me a second.
Is you being 29 the alpha, Kevin?
I think
I hope
I'll be 30 this October. So, yeah.
That sounds like a party that I need to be in Perth for.
Let's see how we go. Let's see what the price is at that time.
It's a party. It's a party. I can see your screen now, Dr. Niraj. You could go.
yes. Sure. Sorry to keep you all waiting. Actually, this Excel sheet was not being I was not getting the option to share this actually. So no worries. We'll start with the discussion now. So the very first one that we have is related to block and transaction size. So as we all know, block and transaction size,
Sorry,
both of them.
Neeraj, can you please zoom
Yes.
into that if you don't mind? Because it's a little hard to read.
Sure.
Yeah, thank you.
Yes.
Perfect. Thank you.
Yeah, sure. So, as we all know, block and transaction size, both of them significantly drive the scalability and throughput of the network. So, this is just a like you can say quick view on how it is actually impacting the entire network as such. So here, if we have a say transaction of 100 bytes, okay, and this is say the block size we have of L1X. So 5 MB is the block size we have, and the block creation time that L1X aims to achieve is 0.5 seconds. So if this is the metrics that we want to go with, then in that case, number of transactions we'll be able to have in a block would be 50,000 transactions. And how it will impact the blocks that are generated in a day. So based on this, like metrics will have, we can say almost 172,000 blocks nearby. So this actually comes down to, if you calculate 100,000 transactions per second. So this is what actually L1X is trying to achieve as such. And this is how the network will be more scalable and have high throughput as well. So next we'll move to the time units. So how the time units have been configured. Let us start with the very basic unit, the base unit. So if you notice, I'll just zoom this as well. Okay. So let us start with the base unit. So say if one slot is my very basic time unit of 0.5 seconds, where we want to create one block in the 0.5 seconds. So these how we have configured these time units. So first of all, let us understand why is it required to have this configuration of the time units. So the very basic purpose is to have like well coordinated network activities. So what are the network activities which are driven by these time units? So say consensus mechanism or block production. These are the like very prominent activities of the network for which time units play a significant role. Apart from that, like protocol upgrades or other things as well would require these base of the time units. So say if I have a slot, basic slot of 0.5 seconds, where I want to have or say create one block in that time. So we have another time unit of one chunk. So this one chunk is formed of 40 slots. So which would actually count to 20 seconds. So implicitly we'll be able to create 40 blocks in a chunk. So similarly, if we have an epoch, so one epoch is formed of 3 chunks. So I guess this is a better representation, sorry. So if one epoch is formed of 3 chunks, then in that case, it is actually constituting 1 minute, 60 seconds, that is 1 minute. And similarly, one cube, the highest time unit that we thought of, is of 3 epochs, that is nothing but like 180 seconds, that is 3 minutes. So we'll be able to create 360 blocks. So these time units, as I said, will be required for the configuration of the consensus mechanisms and the block production, along with selecting the validator set and coordinating the network activities. So now we'll move on to transaction tokenomics part. So in this particular sheet, what we are going to have a view is like which is with respect to a block. So if you notice, we have specified that this entire estimation is with respect to a single block. So this column which we have highlighted consist of the categories of the transaction. Say native transaction, L1X VM transactions, L1X EVM transactions, and the interop transactions. So as we move further in the discussion, you will notice that in all the upcoming further slides, we'll have the same categories of transactions as such in our further discussion for a further discussion as well. And if say these are the different types of transactions I can have under these categories. So more or less we all are aware about this different transactions. So what I would like you all to focus on is like how this tokenomics has been estimated. So the column D is this transaction size is just estimating what would be the transaction size for each one of them in bytes. So that is how the units have been represented. So based on the transaction size and count, in the sense number of transactions, what will be the total size? So for simple example, say if I have size of one account creation transaction is 300 bytes and I have 100 such transactions, then in that case 30,000 bytes will be the size of my all these type of transactions. So in same way we have done the calculation and summed up. So if you notice, this value is somewhere less than 5 MB, because we have uh, considered 5 MB to the 5 MB to be the block size that the L1X can have. So based on that, how much cost would be uh, generated? So definitely we'll be going into more detail how these calculations have been done. So this is the amount which we are able to see in L1X units, and out of which will have some percentage being burned and some percentage being returned back to the network in the form of rewards to the block producers and the validators. So this is how like it is represented. So we'll move further. So what does a transaction cost consist of? So we have this validation cost, invocation cost, computation, storage, address, and memory cost. So if you notice, out of this, validation cost and invocation cost have been burned, whereas the resources which have been consumed of the validator or the block producer, as such, computation, storage, address, and memory. For this, this particular fee has been returned back to them as in the form of rewards. So how is this done? So for that, we'll move on to the next sheet, which is related to the transaction fees. Now, as I said earlier, definitely we have the same categories of the transaction and the different transaction types. So what is not noticeable in this particular sheet is actually two things. First of all, what is one L1X? So one L1X is going to be equal to this 10 raised to 9 N11X. So this NLX is nothing but nano L1X, you can say in simple terms. Okay, so the units that you are able to see in this sheet as such are all in NLX, that is nano LX. So how this has been done? Now, if you notice, as we just now discussed, that validation cost and invocation cost, these two are burned by the network as such, and these four, computation cost, storage cost, address and memory cost, are given back to the network as the rewards. So the thing to note is that we'll have a base fee. Say if we have it as 1 NLX, so based on that, these calculations will be done, and we can represent the same in L1X as well. So the final cost that you were able to see here was in L1X units as such. Apart from that, we can have this speed up factor as well, which is what, like if I would like to speed up my transaction, then this feature can be introduced where you are ready to pay extra for it, and then how the cost would be charged. So definitely the fee that is being burned and the network fee would also be proportional in the same sense. So you might be wondering how these values have been calculated, right, for this different type of transactions. So we'll be going into further details for like each one of them as such. Now what comes is transaction details. So in this, what we're able to notice is, considering a particular transaction type, we have transaction size. So this is a you can say a rough estimate of if a transaction is involved, like how much invocation units would be there of 0 and non-zero bytes. With respect to storage, how much read and write would be required for such a kind of transaction, how many address units you will be required to access. So when we say new and old, it means that some address might be available in the cache, some address might not be available in the cache. So old is the one which is available in the cache and new is the one that you want to access through the RAM as such. So based on that, and finally, how many memory bytes you will be required to access. So memory bytes again would might be with respect to reading or writing. So definitely we'll come to it further how this has been done. So this is what a transaction constitutes of as such, and based on different transaction categories, this estimation has been done. So now we'll move on to the validation quotient. So as you might have observed, for all of them, the validation cost is same as such, which is nothing but the 10,000 L1X NLX units. So in this, how it has been done is, say if there is any transaction which is triggered on the network as such, so there are few checks that a node is required to accept the transaction and process it further. So it might be related to the integrity or the sorry, it might be related to the integrity or the signature authentication or the sufficient balance of the sender of the uh, sender of the transaction. So this way, all these validations are very much necessary for any transaction that is submitted to the network. So that is the reason this cost is applicable for all of them and in the same unit as such. So you might be wondering, what is this GQ? So GQ is nothing but a term that we have designed for global quotient as such. So this global quotient is nothing but you can say equivalent to gas units that we refer in the Ethereum network. Next, we move on to the invocation cost. So when you want to invocate a call to the network or to a function as such, it would consist of some 0 bytes and some non-zero bytes. So as you can notice, if this is the charges, if that these are set based on per byte, how many bytes you want to you will be required for that call, then in that case, how many such bytes you are accessing, based on that this cost will be calculated and you will be charged for it. So as we had seen, this validation and the invocation quotient, these cost will be like burnt as such. Next comes as computation cost. So based on the type of transaction that you would like to initiate, different GQ units would be charged. So these actually consist of the computation or the CPU time that is required along with the network bandwidth as such. Okay, so say if I want to have this create NFT call and I have say 5 such transactions, then in that case the computation cost would automatically be reflected as a 10,000 GQs. Similarly, say if I wish to deploy a smart contract, then in that case, say if I have 10 one smart contract that I want to deploy, then based on that, this is how the computation cost would be charged. Next comes is storage quotient. So again, like for a transaction, we might be required to definitely read some bytes and write some bytes. So as Kevin very correctly said, that reading is free of charge. But if there is a case where you want to change the state of the network, that is nothing but a transaction that you have triggered. And as a part of that transaction, if there is some read that is to be performed, so even in that case, you will be charged as such. And based on the number of bytes that you are accessing, it will get charged. Next comes is address quotient. So as we had earlier discussed, how many address units you want to refer to and get the data from. Based on that, there will be different categories of like how you are like estimating the GQ for it. And finally, what comes is memory quotient. So again, memory quotient is related to the memory that has been accessed for it. So what we have as of now like believed is first 1024 bytes. If a transaction wants to access, then for that the charges would be minimal as such. Okay, but if after 1024 bytes, if extra memory is to be accessed, then in that case the charges would be more. So if you notice, we had this memory accessed as 1500 bytes. So for this initial 1024 bytes, you have been charged with this unit, and for the rest you have been charged with this unit. So this is how these calculations have been done. So this is how we this like entire transaction tokenomics will be actually driven by the different constituents we have for the transaction cost as such, along with the along with these time units, as well as the block and transaction size would also play a significant role in it. So this is from my side as such.
Yeah.
Yes.
Thanks for that. Thanks for that, Neeraj. That was good. So, yeah, as we have this table over here, right? So we have, tried to compute and try to get as much as information as we could for these units. And not to say that, the other layer ones are not cheaper out there. For example, you've got, I think, Mina protocol introduced a pretty good fee structure as well, but I never seen any applications built there. But at the same time, Solana is good, the transaction fee, if the money goes through. But we have created it in a way where we can update certain parts of it as and when required, right? So it's a pretty modular structure where automatically the opcode table has so many attachments in terms of different functions to it, where we can update the cost of these opcodes based on those functions that are natively built into the protocol as well. So definitely, the applications that are building with us can benefit from this structure as well. Yeah. Any questions?
We do have a few random ones and relevant ones. Do you want me to just start at the top and just roll through?
Yeah, please.
What is the relationship between username NFTs and transaction fees, and what will the username NFT earn?
Yeah, that's a good question. The username NFTs, we haven't focused on that, but next month we'll pick it up again because we're working with OmChain on the digital ID solutions, right? And we've got a proposition there for the usernames. So put it this way, anything that goes through the L1X app, including the gaming swaps, it will be shared as a form of revenue to the usernames. So the people who own the usernames will get a part of that revenue, right? And the L1X app infrastructure, I think it deserves a separate AMA on that. We are also going to make that modular where businesses wanting to build certain swap solutions or businesses wanting to build Web3 website solutions to them, they will be able to use the APIs and build as well. So that's a revenue generator model that we want to push. But right now we're focusing on core, but very soon that will come up. And in the marketplace coming up, you'll have the username marketplace, the Node NFT marketplace. All of them will be at the same time on L1X app. So if L1X app people decide to charge a 5% fee, 4% fee, 3% fee on any node NFT sold, that's a recurring fee that you could get to the usernames as well, which I believe could be a big deal.
Yeah, sure. Will the future mobile validator get a share of the ELN pool or FVN pool?
Good question. So at the current moment, the ELNs have their own mechanism on how the trigger cost can be established, and also how the action cost can be established. But at the same time, the action cost is shared with the FBN nodes. So what will happen over here is when the mobile nodes are introduced, they will act like super block registers. And if the ELN and the FBN, who have their own way of setting up the transaction fees up to an extent, they will both be participant in sharing that fee to the mobile node. Because a transaction going through as a ledger, right? ELN also has a database, and even that will have, in the coming time, a way to index as to which ELN to go for what type of information. So they will both be sharing it.
Yeah, I think these next two tie into that a little bit as well. Can node operators set their node fee, and which parameters will be considered to set it?
No, you can't set your own fee. You can set a fee limit. There is a difference here. Now, what I mean by that is, if the users are trying to pay the fees, they have to set a fee limit, like 1,000 L1 and NLX, right? Nano L1X coins. Now, if that's the fee limit there, you could set 5,000. So any transaction less than that wouldn't come to you. But you can't say that when the transaction comes to me, I'm going to set my own fee on top of that, right?
Yeah, that makes sense.
Funny. Yeah.
That's effectively how Ethereum sort of. That's why we have $100 transactions. Is it good to have a minimum transaction fee for users? It is good, but is it good for node operators? They would receive less fee reward. How do you find the best balance between the different interests?
Look at the maximum number of transactions going through on the protocol, right? So in any other protocol, if you see, majority of them are like stablecoin transfers, right? That occupy majority of them. Now, in our case, if the token standard has a deterministic fee model, I think 0.001, 0.01 transaction fee, right now, if you think about it, right, there is a hard cap in terms of like how many transactions can be processed, right? If you think about it, like there is a ceiling, but what you can do is take the ceiling and multiply it by that minimum number. You'll get astounding numbers in returns. So 100,000 transactions a second, multiply that by 24 hours and multiply that by 0.01 a day for a single node, for example, right? So your numbers are like astoundingly high. But again, the block rewards are also there, right? So you don't have to only rely on transaction fees. You've got the block rewards as well as the proposer. And right now it's randomly done so that everybody gets an opportunity to propose a block and get the block fees.
How secure is the new structure of the FEN and ELN nodes?
When you say structure, there are like various pointers, or security. There are like various pointers. For example, state changing behaviors, like can someone fork it and go and produce their own blocks, or the connection between ELN to FVN structures. At each and every places, there are these cryptographic algorithms that are placed to re-verify if you are the owner or you have permissions to actually call them. And also at the smart contract level, there are these security features. So Hashlock has been auditing the smart contract, but when it comes to the consensus side of things, I mean, they will audit it, but the whole cryptographic way of doing things is derived from the past, like Bitcoin. So we do feel that if you think about the previous structures on decentralized delegated proof of stake as well, it's a pretty secure way of doing it. Only when the mobile nodes come through, that's when we have to be careful, and that's why we are introducing that later on.
That makes sense. Tech-wise, does Chainlink have anything L1X oracles don't?
I think it does. Expensive fees. Chainlink has expensive fees that L1X does not. Yeah.
I'm glad you clarified that. Okay. So this is a pure degen question, I can tell from Lucius Suspicious. Is it possible to create meme coins on L1X directly after TGE?
Absolutely. Interoperable meme coin. Yeah.
Oof, Beardcoin, it's a go. I'm sure that must be
Yeah,
joy.
I had a concept about, and I'll explain this meme thing, right? So, and this concept was about the raise, right? Initially, because when we were trying to raise, of course, it's a long process. You got to know people and do it. But I had this weird idea of raising capital, and it's soon, because I was not the only person making decisions, right? But even I thought it's very risky. The idea was the one coin chain. Like before layer one, the name would have been one coin chain, which is we only raise $1 each from everyone to increase decentralization and to raise the capital. So just the dollar chain, meaning you can't invest more than a dollar with a single address, right? And if you created 10, 100, how much would you want to do? So that would have created the marketing buzz around that everyone can only have $1 in the beginning. And then it would grow, like one person sending the other 2, 4, 6, or 8, 16. That was the thing. But you could take that in a meme coin, the $1 meme coin, just deposit on $1.
Be very interesting. Very interesting to see the marketing mechanics behind that. There's a challenge. What does that look like for the community? I think. What could you build with the one coin, the one coin?
The one L1X coin, like meme coin, right? So only accepting one L1X coin for the meme coin kind of thing, and the transaction fees are negligible, so people wouldn't mind sending it. Like, yeah, here you go.
Yeah, minimal risk, maximum reward. It's what every DGM wants. How is the money generated in transaction fees distributed?
The 50% is going to the full validator nodes. A certain part of that, like for example, I think so, 10% or 15% is going to the ELN, event listener nodes, or Xtalk nodes, and the remaining money is going to the foundation, and or some of that is getting burned. So that is the structure. But what we are actually going to do is, because the block rewards are pretty high, right? So the block rewards are, like, I think the highest for any layer one today. I have not seen any layer one with that block rewards initially, but we will increase the transaction fees towards the full validator and event listener nodes and reduce the block validator nodes after some time. We want to burn a lot of coins that we are giving out. So that's why we are taking the risk or the burden of burning those coins and not putting it on the node hosting people. So they have a deterministic fee model initially.
Let me just see if I've got this right. To create a token on L1X, what are the major criteria and benefits one gets in terms of node sustainability? What do we expect from L1X in a few months, 2 to 3 months coming on nodes, running any features to add?
Initially, you have your hosting, right? So you'll be hosting your full validator node and event listener node. The full validator node, again, automatically decides in the coming time, will be able to feature shard it and automatically decides, right? On the ELN side, you will be able to configure pricing based on who wants to register what kind of information with you, right? So if someone has an internal database and API wants to send it across to the chain, they have to use the L1X infrastructure because we are not compatible with Chainlink, or we could be, but or layer zero, but it could be, but we don't want to go that route. So that feature of fee modification can come through. But apart from that, I think I don't think the node operators itself need to worry too much about changing things. We have gone towards a self-managed model, but less operational involvement required from you. Yeah. Feature-wise on the protocol, we will release the full validator nodes, 80 full validator nodes next month can host event listener nodes. But then moving towards it, we have the Bitcoin integration coming in. So we are almost there with it. And I think sometime in April, we'll be in a position to release it to the community to test it. So yeah, apart from that, we do have few other features that we are working on, but they are on the back burner right now. and I don't want to give out too many alphas. But yeah,
just a little bit of
Yeah.
alpha. I don't think this is necessarily a super serious question, but after all these technical AMAs, when will we receive our bachelor in blockchain?
I think we should definitely start the University of L1X and issue out certificates, right? But you don't need a bachelor in blockchain. You don't need a diploma. You don't need a PhD. Like, of course, I'm doing my PhD part. You don't need a PhD in blockchain. I think all you need is like a common sense mind to ask good questions, right?
Is there a cross-node master clock?
There is the global transaction ID that is generated. And then based on that global transaction ID in the global TX ID body, there is a timestamp. So that could be the master clock that you may be thinking of.
Yep. Clarity on burn fees. Are burn fees 13.7% of the cost?
It could be. We can give out exact numbers once we release this Excel. It could be, but yeah, it's going to change. Like, it's going to be dynamic. So I don't think we should give out like a static number right now.
This one's got a couple of parts to it, so let me just roll through it. Could you explain why there are different gas fees on
Yeah,
Ethereum?
I went through that one.
Oh, yeah.
I went through that. That's a very interesting question. Okay, so correct me if I'm wrong, but the question is, when you are sending transaction from Ethereum, swapping, let's say, from Ethereum to any other chain, it actually costs you more. But when you are trying to swap into Ethereum, it costs you less. Yeah. All right. Now, when you are actually saying that I have USDC on Ethereum and I want to swap it with BSC USDT on Binance Network, the way you are actually sending that is generating the global TX ID and checking a lot of conditions, creating a transaction meet that is going to be used into the event on Xtalk. That is why when you configure that, that's going to be expensive because you are going through multiple opcodes or lines of code over there to execute it. On the destination, you are saying that I have confirmed this, just transfer it across, right? Check the global TX ID and transfer it across. There are fewer lines. So that would be one reason why it would cost less if the destination is Ethereum versus if the destination source, the source was Ethereum. So you would pay more over here than on the other hand. And that analogy we have also faced in Bitcoin. It's very interesting. In our case with Bitcoin, that does not apply, but we would have faced that if we use contemporary ways of swapping Bitcoin with other chains. Like right now, you can swap into Bitcoin. You can swap from Bitcoin into 7 EVM chains and Solana. So we have done that. But from Solana, if you want to go to Bitcoin, that is what we are working on because that requires threshold signing signature, and that could become expensive, right? So on the Bitcoin, it's on the flip side, basically, if I'm not wrong.
Why is it an NLX and not a Kev?
We'll have to ask Neeraj for that.
That would be amazing. I think we've answered this one earlier, but I'll just recap. Are L1X app NFTs holders going to get part of the transaction fees in L1X app? How L1X app NFT holders can earn from app after launch? Please explain briefly. I think we touched on that.
Gonna get part of the transaction fees in L1X app. How L1X app holders gonna earn from app? Yeah, as I mentioned, right? The swap fees, they will get a part of it as well. Anything that is built on L1X app and other people using the L1X app APIs will get a fee there. So, for example, we were speaking to one of the reward research companies and they wanted to build a widget on L1X app, but then you would charge a fee. So the whole L1X app model is like this fee charging model where you want to delegate people to build on L1X app and then you charge a fee on there.
Excellent. I think that's it for all the questions from top down. If there's anything I've missed, or you feel like I haven't got anything in there, just please throw in the comments now. In the short term, let's head for your wrap up statements. Dr. Niraj or Kev, who would like to go first? Oh, actually, one more question would be going over the node reward details.
I think last time we went through it, so please look at the last one. We did an AMA on that specifically. So we have talked about the node rewards over there as well. And just go to L1Xapp.com. L1Xapp.com, go to the node NFT section. And on the left-hand side, the second tab is the calculator. So there you will be able to find information based on the node reward. So just put in the numbers over there, play around with it, and you'll get it. It's like around 40% block rewards.
And one from Sleazy, you said previously dynamic fees equals expensive to build. Can you elaborate why that is?
You say dynamic fees expensive to build. I don't understand that question. You said previously dynamic fees expensive to build. Oh, okay. Maybe this is more about, okay, I think the constant fee model that I was talking about. All right. So the dynamic fees, you take it this way, right? Let's say you've got a business that sells popcorns to a movie theater, right? You go into the movie theater and you buy the popcorn, and the movie theater guy outside with the ticket gives you a free popcorn coupon, and you give the coupon and you get your popcorn. You want to buy another popcorn, you got to pay him the money. Now, in this particular case, there are like multiple contracts that will have to be built to register the fee of the ticket fee, the popcorn thing, and extra, right? Now, let's say 2 smart contracts you have built are deterministic. The third one, to get the popcorn, to buy the popcorn from the other model, you have to pay a heftier fee because the transaction fees can fluctuate. So how do you build a business model concerning that one popcorn is for free, the other one is not, and I got to buy it from 2 different places while still maintaining the average value of that particular product? So there are these like many use cases that will come up in the future, and their constant fees are always preferred over dynamic fees.
Consensus mechanism video ?
We did a third one, so I think you must have missed that. So if you go to the Tech Tour 3, or if you have any specific questions on consensus, happy to answer that as well.
Okay, we take this last one. Someone asked in the Discord about possibly having an AMA to explain about how you think the L1X coin is going to derive value from partnership, earning tokens per transaction, etc., and hence at the end appreciate in price.
I mean, the simple answer to that is more demand of L1X coins, because people require for the transaction fees and all those stuff, right? But again, I think this is a long-term play, right? So I don't know. I mean, apart from the fact that the whole tokenomics had changed to make sure that the price remains healthy, and I'm not okay. I have been, into a company before their share prices were a thing, but I am not behind appreciating the value of L1X coins price. That's not my job. Like, that's not what I am here to do. All I can do is increase the utility of the protocol and make sure people use it. If the prices have to increase because of that, it may happen. If it doesn't increase, it may not happen. But I can't control the market.
Perfect answer. I think that should be the focus, right? That's we want to increase use case utility, what it's actually here for. That's the design of the coin inside the ecosystem. So it makes perfect sense. But obviously, with more use case comes more demand. That's yeah. I mean, that's simple economics. Will we work on the L1X as gas fee next?
Yeah, we're working on it. But first, we're trying to solve the Xbox and Node NFT for you guys, right? So you guys can go and opt in. And please, this is a request. Those who are going in, I've seen many of you have opted for 5 Node NFTs. Please don't do it. leave the node NFTs for someone else as well. Like if that continues, then we might be forced to enforce a limit. We might be forced to enforce take down 5 to 1 for everyone who has opted for 5. Please don't do it. Like, give an opportunity for everyone else as well to go and get a node NFT. We want it to be as decentralized as possible. Please don't do it.
Fair and reasonable request. What kind of data will be stored in FVN's the 500 gigabyte requirement, which I think this next one probably rolls into. If block size is 5 megabytes and block creation time is 0.5.
Blockchain related data.
Yeah. Is that sustainable in the long run?
I think this person, whoever this person is, they ask a very interesting question. Let me know if you are in accounting or finance by any chance. But anyways, if you look at all the blocks out there, right, 95, 98% of them, or maybe more, is all vacant, meaning they're empty. So only if the transaction has data, it will be accumulated to that. Now, when someone says that we are 100,000 transactions a second, I think the question should be, how many transactions are actually happening? Right? And you'll be surprised to see certain chains. You'll be surprised. Like, when they give you the block information, they are saying how many transactions are actually possible. They're not showing you how many transactions are done. That's why you see 10 million, 100 million transactions. But one contract call can be 10 transactions, internal cross-contract transactions, right? So is that 10 transactions? So many times what you see over there and you do the numbers, it doesn't add up, right? So don't believe how many transactions are there, is it possible or not? Just see how many valid transactions are going through. And that you will get to know by looking at smart contract logs, if you want to actually go and deep dive into it.
It's homework between now and the next AMAs. Everybody needs to do a quick audit of smart
because
contract.
It's amazing. Once I had I was on a call with one product, and I was like, okay, we are thinking to build on X. I said, I don't know why. They said, why? I said, because they can do 125,000 transactions a second, and this does 110. I said, whoa. So it's funny because he necessarily is not done his homework. He's heard somewhere about it, and he's made up his mind because of that. So I think it's important to go and ask, what constitutes this transaction? Are you talking about a cross-contract call? Are you talking about pure state-changing transaction? What part is it? Because just by writing transaction, that doesn't mean that these are unique state-changing call transactions.
Devil in the details, so to speak. I think that's we've covered off on the questions I can see here. So yeah, let's roll closing statements. Dr. Niraj, would you like to go first?
Yes, thanks, Joe. So, like as we have seen today, the different constituents where the computational resources of the nodes are consumed, for which will actually constitute the cost of a transaction as such. And based on that, like how much a validator or say you can say a block producer, how much they'll be able to earn. So, based on a single block, like having a size of say 5 MB max in L1X network, how many transactions they'll be able to include and how much L1X coins they'll be able to generate. So I guess we have got a fair idea related to the transaction and the block size related fees and rewards as such. So that is from my side.
Yeah. No, first of all, I would like to thank the community, and especially to those people who are awake. I think, of course, the timing thing, but I went on this AMA and we did another one live stream at, I think, 3 a.m. AWST. But so a lot of people, like 100 people jumped in. And I was explaining about the Xperk and the node sales program. So first of all, we appreciate your patience on that, right? And we are making changes to release it. And the next ones, we will focus upon the hosting of the node, which is very important. Nodes have to be there to take up the traffic, because once we go on this spree of onboarding projects with the updated developer docs, we need the nodes infrastructure up. And just be a bit patient. We are getting there, that we're trying to do as much as we can. We reduced our sleeping time. Everybody's not sleeping as much as they have to, and it's not necessarily because we don't want to, but it's like even if we sleep, we get up quick because of the workload. So thanks for your patience, but please be more patient when we require you to be more patient as well. Thank you.
Yeah, I think that's a big thing from the community too, towards the team. You can see the dedication there. It's to be awake at 3 a.m. Perth time, and then to in that state where you're dealing crisis wise and everything as well, trying to get things done, and still taking the time to jump on an AMA, open AMA with the community in Discord. That shows proper dedication to not only the protocol and obviously getting things done and getting them done right for everybody, but also shows care for the community and everybody inside of it. Obviously, not an ideal situation, but that's part of the growth. It's part of the teething. It's part of the place of where we are, I think, in the journey. And it's only forward from here, right? And we definitely appreciate, I think, from all ends, we can appreciate all you D-gens that stayed up for 2 days in a row. And I see in the comments here, it's like 1.5 hours sleep before work or 2 hours sleep before work. We appreciate you guys, but we also appreciate the team knowing that they've been awake 2 consecutive days as well, trying to get things pushed out on time for everybody as well. So
I think the community has been amazing. Like, there were certain people who had problems in experts, and there were certain people saying, "Oh, again, the other guys are like, no, it works. They're pushing it hard." So, just to give you some numbers, there were 18 people who had problems. 72 went through. So 18%. Initially, I thought it'll be more than 20%, but 18%. And we have already figured it out for these people. And I think all those people who did not go through, they have by mistake done the data sanitization. And we will also make sure that you can redo that, right, if required. But as a show of faith, that we respect that you were awake and you had problems and you tried. Each and every account that has had problems will be getting 1,000 L1X coins from my side, from my account, to those accounts. We have the wallet addresses. So anyone who had problem, 1,000 L1X coins will be there. Not to say that you create problems in the future, because this is not, after this, we are not going to give it again. It's not going to happen again, right? So there are those 18 accounts where 1,000 L1X coins will be going as well to you. But thank you so much for being patient and showing so much of appreciation in Discord. It really means a lot to even the new coming people on Discord.
Yeah, even that, it just shows how much care you have for the community as well. And like I said, it's reciprocated both ways. I see that we've already, you don't know this yet, Kevin, but we've already planned the office party for your birthday. October, I've got the dates down. It's happening.
Yeah, I just hope that everyone can plan their things, but yeah, if we can celebrate, why not?
Absolutely, yeah, absolutely. But that's it. So I think we'll wrap that there. But it's been once again a really informative space, and these have been so good. I think the deep dives into showing the tech and getting those really detailed questions answered about exactly how things work, and obviously we have the resident experts here as well to make sure that the information we're getting out there is dead accurate, and we've got, of course, the Kevin board to explain exactly what that looks like. So we'll keep these coming as well. We've got more planned throughout. We're getting ever closer to the moment, to launch moment. So we're under 2 weeks now, I believe. So things are starting to ramp up significantly. But once again, thanks to everybody for being here, sticking with us, and obviously we will see you on the next one. But there's huge things coming down the pipeline. So we'll see you all soon. Thanks for being here.
Perfect.
Thank you.
Thanks, guys.